Now we will discuss the glycolysis process or glycolysis pathway. Glycolysis, the word glycolysis derived from the Greek word glykos. Glykos means sugar. Lysis means splitting. Lysis means splitting. Lysis means splitting. Splitting of glucose molecules is called as glycolysis. This glycolysis involved in the 10 steps. For example, this is the one glucose molecules or sugar molecule. C6H12O6. This is the chemical formula of glucose. This glucose partially oxidized to form two molecules of pyruvic acid. Two molecules of pyruvic acids. This pyruvic acids. This is glucose. This glucose, after 10-step reactions, finally it gets two molecules of pyruvic acids. This pyruvic acid is end product of the glucose. End product of the glycolysis or glucose pathway. This is C6H12O6 chemical formula of the glucose or sugar. This is called substrate. Substrate nothing but in this process which is initiate of the glycolysis is called substrate. Two molecules of pyruvic acid is the end product. Which is the end product of glycolysis means pyruvic acids. How they will 10 steps will converted the how can you will say will explain the pyruvic acid how to form this from one molecules of glucose we will discuss flow chart. One more, this is glycolysis. This glycolysis having the different names. First core respirations. This glycolysis is also called as the core respiration. One more name, EMP pathway. EMP pathway. EMP pathway nothing but this is three scientists. We want to call three scientists. The name of scientist is Germany, belongs to the nation Germany scientist. E stands for embedded. M stands for Meyerhoff. P stands for Carnus. Embedded Meyerhoff, Carnus. These three scientists combined to form discovers the glycolysis pathway. We will discuss the glycolysis 10 steps with the enzymes. This is glucose. Glucose chemical formula is C6H12O6. C6H12O6. This glucose is converted into glucose 6-phosphate. Glucose 6-phosphate. In the presence of enzyme hexokinase. In the presence of enzyme hexokinase. In the presence of enzyme hexokinase. By the required magnesium ions. By the required magnesium ion. Glucose is converted into glucose 6-phosphate in the presence of enzyme hexokinase by the required magnesium ions. Here how many carbons glucose? 6 carbons. How they will connected from glucose to glucose 6-phosphate? One phosphate is lost. That lost of phosphate is attracted to 6th carbon of the glucose structures. Here, then this ATP is converted into ADP. Here ADP stands for adenosine triphosphate. This adenosine triphosphate, how many phosphate is there? Triple phosphate. Three phosphates. Nothing but triphosphate. Out of 3 phosphate, 1 phosphate is lost. That last phosphate attached at 6th carbon of the glucose structures. 6th carbon of the glucose structure. Then this glucose is converted to glucose 6 phosphate. We will see example. Glucose, how many carbons? 6 carbons. This is 6 carbons. First, second, third, fourth, fifth, 6 carbon structure of the glucose. How from 1, 2, 3, 4, 5, 6 carbon compound. How one more phosphate is removed. That removed phosphate at the 6th carbon place. 1, 2, 3, 4, 5, 6. This phosphate attached to 6th carbon place. Then this glucose is converted into glucose 6 phosphate. This glucose 6 phosphate by the presence of hexokinase enzymes. Hexo means 6. Where the kinase word comes, removal of phosphate or addition of phosphate. Then glucose 6 phosphate is again converted into fructose 6 phosphate. Fructose 6 phosphate. Fructose 6 phosphate. In the presence of enzyme, fructose hexoisomerase. Fructose or phosphofructoisomerase. Phosphofructoisomerase. Phosphohexoisomerase. Phosphohexoisomerase. This fructose 6 phosphate is converted into or modified or changed into fructose 1,6 bisphosphate. Fructose 1,6 bis or diphosphate. By the presence of phosphofructokinase enzymes. By the presence of phosphofructokinase enzymes. Phosphofructokinase enzyme. With this help of phosphofructokinase enzyme, fructose 6 phosphate is converted into fructose 1,6 bisphosphate. During how they will convert to fructose 6 phosphate is converted to fructose 1,6 bisphosphate means here one phosphate is lost. ATP stands for adenosine triphosphate. ATP converted into ADP, adenosine diphosphate. But here 3 phosphate is there. Out of the one phosphate is lost. That last phosphate is attached to first carbon of the glucose structures. Then the phosphate is present at first carbon and 6th carbon. Here first carbon, second, third, fourth, fifth, 6th carbons. Then this fructose 6 phosphate is converted to fructose 1,6 bis or nothing but di2. One phosphate present at first carbon, another phosphate present at 6th carbon. That 1,6 bis phosphate. Here. This fructose 1,6 bisphosphate is bifurcated into 2 molecules of triose phosphate. This fructose 1,6 bisphosphate is bifurcated into 2 molecules of triose phosphate. One is DHAP. Another one is glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. This glucose is a 6 molecules of carbon compound. Glucose 6 phosphate is also 6 carbon compound. This fructose 6 phosphate is also called 6 carbon compound. This fructose 1,6 bisphosphate is the 6 carbon compound. Here how many carbons? 6 carbon. Out of 6 carbon, 3 carbons removed from DHAP, another 3 carbons move from towards the glyceraldehyde 3-phosphate. This fructose 1,6 bisphosphate is bifurcated into two molecules of triose phosphate that should be DHAP, dihydroxyacetone phosphate. Another one is glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. This DHAP and glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate is also 3-carbon compound. 3-carbon compound. Sometimes DHAP is converted to glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate is converted to DHAP in the presence of which enzyme? Triose isomerase phosphate. Triose isomerase. Triose isomerase phosphate. Triose isomerase phosphate. Here, fructose 1,6 bisphosphate is bifurcated into two molecules of triose phosphate by the presence of aldolase enzymes. Aldolase enzymes. The presence of aldolase enzymes. The presence of aldolase enzyme. How many steps are completed? First step, second step, third step, fourth step, fifth step. We will discuss the sixth step. Here, glyceraldehyde 3-phosphate. This glyceraldehyde 3-phosphate is converted into glyceraldehyde 3-phosphate into 1,3 bis-phosphoglyceric acid. 1,3 bis-phosphoglyceric acid. PGA, phosphoglyceric acids. Glyceraldehyde 3-phosphate is converted into 1,3 bis-phosphoglyceric acid by the presence of dehydrogenase enzyme. By the presence of dehydrogenase. By the presence of dehydrogenase enzymes. Here, how many phosphate is present? 3-phosphate. 3-phosphate is present. 3 carbon is present to first carbon. 1 phosphate is present to third carbon. Here, see. For example, this is the first carbon, second, third, fourth, fifth, sixth carbons. Phosphate is present already present to third carbons. One more phosphate is added from the cytoplasm. That is called PI. PI stands for inorganic phosphate. One phosphate is attached to first carbons. Here, first carbons. Then this glyceraldehyde 3-phosphate is converted into 1,3 bis-phosphoglyceric acid. Here, phosphate present at third carbon. One more cytoplasmic phosphate attached to first carbon. That's why 1,3 bis-phosphoglyceric acids. Here, NAD is also the presence of dehydrogenase enzymes. NAD plus converted into NADH2. NADH2. NAD stands for